In this video, we're going to talk about equilibrium with respect to ionic compounds' ability to dissolve in water. So when we're talking about equilibrium, that is a situation where you have forward and reverse processes happening at equal rates, and you end up with no net change in the concentration of the product or the reactants. So when we're talking about equilibrium, a lot of times we represent the ratio of products to reactants with a value called K. Now K, again, is concentration of product over the concentration of reactant, but they must be in the same phase. Now when we're talking about doing this for an ionic compound, such as, say, silver bromide, okay? The reactant in the process of dissolving is the silver bromide, which is a solid, and the products are aqueous ions of silver and bromide. So if we set up a K expression for this, you have silver ions times the bromide ion concentrations. Again, these concentrations represent the molarities over the silver bromide solid concentration. And the issue with that is this is a solid and it's not in the same phase as the rest of the solution. And if you're not part of the solution, you're part of the precipitate. And you don't count in equilibrium expressions. So what this lets us do is look up, these are values that are known and you can find them everywhere. And what it lets us do is calculate the maximum concentration of a given ion that you could have in a solution that's simply of this ion. We'll do more complicated problems when we get to the equilibrium unit. But for now, I just want to introduce the concept of how you can use these values to calculate how concentrated it can really be in a solution and how soluble it really is. Instead of just saying soluble or insoluble, actually giving you a number to represent that with. So if we ask, what's the maximum concentration of silver in a silver bromide solution? No other ions present, just water and silver bromide. So since the amount of silver is going to be equal to the amount of bromide dissolved in the solution, we can say that they're equal to each other. And if we're solving for those values, we can represent them each as x. So we could represent this whole equation as KSP is equal to x squared. And then we looked up the solubility product for silver bromide and saw that it was 5.0 times 10 to the negative 13. Taking the square root of that value, we get that you have 7.07 times 10 to the negative 7th moles capable of dissolving per liter of solution. Not a very high concentration. In contrast to that, I looked up the KSP at the same temperature condition, 25 degrees Celsius, and saw that for sodium chloride, that value is 39. Taking the square root of that, you get that you can have a maximum concentration of sodium chloride in the solution of 6.2 molar. So that's about 10 million times more sodium ions that you could dissolve than you could silver ions for these given solutions.